Hi students, hope you all studied the solution chapter complete theory, the important areas, how to express the concentration of a solution, all those terms and their numerical, Henry's law, Raoult's law, theory, numerical, what are ideal solution, non-ideal solution, their classification, their property, mainly example. There are so many previous year questions they were asking about the examples. They will give you one example, whether it show positive deviation, negative deviation, whether ideal solution, minimum boiling, maximum boiling, azeotrope, like that. And graph is very important, and colligative property must questions. Let's see 2024 board exam, what they were asked from solution chapter. Question number 1 is a numerical one. Ishan's automobile radiator is filled with 1 kilogram of water. So 1 kilogram, that is the weight of solvent, right? So weight of solvent is what? WA. Weight of solvent is given 1 kilogram, that is equal to how much? 1000 gram. Ready? How many grams of ethylene glycol? So that is a solute, right? How many grams of ethylene glycol? So WB. Weight of solute we need to calculate. Its molar mass already given. So MB is already given 62 gram per mole. Ready? Must Ishan added to get the lowering in freezing point. See, what is the lowering in freezing point? That is delta TF equal to 2.8 degrees Celsius. KF for water is given. See, KF. What is KF called? Cryoscopic constant. That is 1.86 Kelvin kilogram mole inverse. Dear all, directly we can apply our numerical equation. What is that? Delta TF is equal to I into KF into molality. That means WB by MB into 1000 divided by WA. So delta TF already given 2.8. Okay. See, dear all, delta TF. So you may think, sir, it need to convert this 2.8 degrees Celsius into Kelvin. No. Because what is delta TF? Delta TF is TF naught minus TF, right? This is already the difference between two temperature. So when you take the difference, whether you calculate it in degrees Celsius or Kelvin, no changes, right? Because if you suppose you converted into Kelvin, whenever you take the difference, that 273 cancel, right? So no need to convert, okay? So I, Van Hoff factor, what? Ethylene glycol. For we studied I value for known electrolyte is 1. So 1, that is, just leave it. KF is given 1.86 into WB. What is the weight of solute? That is supposed to calculate. MB is given 62 into 1000 divided by WA is the weight of solvent. That is also 1000. So WB is equal to 2.8 into 62 divided by 1.86. Around you will get it all 93.3 gram. Don't forget, WA and WB are what? Weight, right? Its unit is gram, whereas MA and MB is what? Molar mass, right? Its unit is what? Gram per mole. Because unit, if there is a mistake, they will cut half mark. Careful. There is one more question. What type of deviation from Raoult's law is shown by ethanol and acetone? Where we studied ethanol and acetone. That is positive deviation, right? Ethanol and acetone shows positive deviation from Raoult's law, and give reason. Because in positive deviation, AB interaction is weaker than which one? AA and BB interaction, right? Yes or no? So the question, what type of deviation from Raoult's law? That's ethanol and acetone, because ethanol and acetone while you mixing. Suppose you consider ethanol is A component, acetone is B component. The ethanol interaction is stronger. Acetone interaction is stronger, but ethanol and acetone interaction is weaker. Therefore, AB interaction is weaker than AA and BB interaction. Therefore, it follow which type of deviation from Raoult's law? Positive deviation. And all other cases also you can write. What are the other information we studied about positive deviation? Delta H mixing is greater than 0. Delta V mixing greater than 0. PA greater, PB greater, P total greater. And they will form which azeotrope? Maximum boiling azeotrope. All the minimum boiling, positive deviation form, minimum boiling azeotrope, all the cases we studied. So what is the main reason the acetone and ethanol form positive deviation? Mean the interaction based on positive deviation. There is actually one more or question in this 2024 board exam. Same one numerical, and here instead of Raoult's they asked state Henry's law. You know the definition. Correct, my dear. Next question, 2020 paper. See that. Identify which liquid will have higher vapor pressure. Which one having higher vapor pressure at 90 degrees Celsius? Boiling point of two liquid. A boiling point is given 140 degrees Celsius. B boiling point is given 180 degrees Celsius. See, this is the boiling point, right? So boiling point, how related to vapor pressure can you say? See all, boiling point increases means what happened? They have very strong bonding, right? Stronger the bonding between molecule, it won't vaporize. So higher the boiling point, less vapor pressure. What is the point? Higher the boiling point means very stronger the bonding. Stronger the bonding, less vapor only can generate. They can't able to evaporate. So higher, the one which having highest boiling point having lowest vapor pressure. So they're asking identify the liquid with have higher vapor pressure. That means lower boiling point, that is A. A having higher vapor pressure because its boiling point is less. Lesser the boiling point, higher the vapor pressure. Okay, identify. Predict the state of the solute in the solution in the following the situation. First one. What happened? Van Hoff factor is found to be more than 1. We already discussed. I value can be greater than 1 during what? During dissociation. If the solute undergo dissociation, we can say that dissociation, we can say the molecule when undergo dissociation, the I value will be less than 1. And greater than 1, and I value will be less than 1 during what? Association, right? During association, I value less than 1. And we studied I value can be 1 for which one? Non-electrolytes, right? What is mean by non-electrolytes? The one which do not undergo dissociation or association in water. Only solution. So when I value is found to be more than 1 means you can say the solute is undergoing dissociation. Similarly, I value found to be less than 1 means the particles undergo association. Like that we can say the situations of the solute. What happens? Again 2020 question paper, my dear. What happens when a pressure greater than osmotic pressure is applied? We studied our osmosis process in detail. Here we have the solvent, here we have the solution. What happens if you apply a pressure here which is greater than the osmotic pressure on the solution side through the semi-permeable membrane? What happens? Normally solvent move from solvent to solution, that is called osmosis. If you apply a pressure to stop the process, osmosis called the osmotic pressure. If the applied pressure is greater than osmotic pressure, solvent starts to move from solution to solvent. That is called what? Then reverse osmosis takes place, right? So reverse osmosis takes place. One more, acetone is added to pure ethanol. What happened? Acetone and ethanol, where we studied, just we discussed now, right? Acetone and ethanol form positive deviation. It will deviate from Raoult's law, and it is an example of positive deviation. All the 5 points we discussed about positive deviation, you can write here. Okay, so acetone and when added to ethanol, it deviates from Raoult's law. It is a non-ideal solution and it shows positive deviation. Next one, state Raoult's law. We know Raoult's law says that for a volatile component in a solution, the partial pressure is directly proportional to its mole fraction in the solution. So Pa is equal to what? P naught A into chi A. Or you can define that partial pressure of any volatile component is the product of partial pressure of the vapor pressure or partial pressure of the pure component into its mole fraction. Like that equation also we can define it. Write 2 characteristics of the solution which obey Raoult's law at all concentration. What they call ideal solution. See, ideal solution, 5 points we discussed. Can you say one by one all? First one we can say it obey Raoult's law. So Pa equal to P naught A into chi A. Pb is equal to P naught B into chi B. Even P total is Pa plus Pb. and delta H mixing is equal to 0, delta V mixing equal to 0, and AB interaction approximately equal to AA and BB interaction, and they do not form azeotrope. Like that we can give it, and can just give some example also. Do you remember what all example we studied for the ideal solution? N-hexane with the N-heptane, bromoethane with the chloroethane, benzene, toluene, like that. Examples also we can write it. Give reason. A decrease in temperature is observed on mixing ethanol and acetone. Again, see the example. Ethanol and acetone form what type of deviation? They will form positive deviation. In positive deviation, you know, AB interaction is weaker than AA and BB. That means after mixing, their bond strength is weak. If the bond strength is weak, you know, they will boil at a low temperature. That's why they form minimum boiling azeotrope. So why there is a decrease in temperature is observed? Because their bonding is weaker. Weaker the bond, lesser the boiling temperature. Potassium chloride. What is potassium chloride? All KCl, right? Potassium chloride solution freezes at a low temperature than water. We already discussed that. As the number of particles increases, what happens to boiling point increases. But what happened to freezing point decreases, even vapor pressure decreases. We studied, right, my dear? Yes. So as the number of particles increases, what happened to freezing point decreases. So potassium chloride is a solute, right? So it will give you more particle. So potassium chloride solution freezes at a low temperature than water. Water is a pure solvent, right? When you add KCl, it becomes a solution. So as the number of particles increases in the solution, what happens? Freezing point decreases, boiling point increases. Ready? That's what we call depression in freezing point. Give reason. An increase in temperature is observed on mixing chloroform and acetone. Where we studied chloroform and acetone? Check it all. I told you when we studying the theory, these examples are very important. Chloroform and acetone, where we studied? Can you say? I think we studied in negative deviation. Negative deviation. So why there is an increase in temperature? We know in negative deviation, AB interaction is stronger than AA and BB interaction. What? AB interaction is stronger. So stronger the bonding, greater the temperature, higher the boiling point. Next question. Aquatic animals are more comfortable in cold water than warm water. We know warm water, cold water difference is what? Temperature, right? You know, temperature is inversely proportional to the solubility of the gas. As temperature increases, the dissolved gases escape from the liquid. So aquatic species won't get enough oxygen for their respiration, right? So cold season, temperature is low, so more gas is dissolved in liquid, so aquatic species are more comfortable. But in summer season, as temperature increases, dissolved gas, oxygen gas is less in amount. Ready? And that's over, right? Okay, next question. Out of 0.1 molar aqueous solution of glucose, okay, and 0.1 molar aqueous solution of KCl, which one will have higher boiling point and why? See all, very simple. As the number of particles increases, boiling point increases. That's it. You know, glucose is a non-electrolyte. They do not undergo further dissociation. It exists as one. But KCl, when splitted, you will get K plus and Cl minus. So this is giving more number of ions. Or also, you know, delta TB is equal to I into KB into M. Here molality constant, KB for water is constant, only delta TB depend on I value. Glucose I value 1, KCl I value 2. Of course, what happened? Boiling point increases with an increase in number of particles. So this one having highest boiling point. Next one. Predict whether Van Hoff factor I is less than or greater than 1 in the following. We discussed this special case in class. This is our acetic acid. We discussed in class or not? Acetic acid when dissolved in water, it dissociates. So in water, dear all, acetic acid dissociate. It will give you CH3COO minus and H plus. So I value is equal to 2. How to calculate I value? Number of particle after dissociation by before. So after 1, 1, 2 are there, before 1, so 2. So acetic acid was dissolved in benzene. We discussed in benzene solvent, acetic acid exists as a dimer. So how it is? 2 acetic acid join, you will get 1 dimer, like one species. So what is the I value here? How many particle after dissociation? Association 1, before association 2, so 1 by 2. So during association I value less than 1, during dissociation I value greater than 1. Ready? Next question is, what type of azeotropes mixture will be formed by a solution of acetone and chloroform? Hope you clear now. Examples are very important. Previous year they are sure. Acetone and chloroform belongs to which deviation first? Negative deviation. Okay, my dear? They will form negative deviation. Acetone and chloroform, which deviation? Negative deviation. So negative deviation form which azeotrope? That will form maximum boiling azeotrope. Maximum boiling azeotrope. Okay. Negative deviation form which one? Maximum boiling azeotrope. Because you know the reason, AB interaction is stronger than AA and BB interaction. Justify on the basis of strength. See, this is they're asking strength of the bonding. Ready? Give reason for the following. Aquatic, that already we discussed. Aquatic, repeated question, aquatic species. Next, second question, all of you. At a higher altitude, we studied mountain climbers and all. Higher altitude, people suffer from anoxia resulting in inability to think. What is the reason? Higher altitude, atmospheric pressure is less. According to Henry's law, connect with Henry's law, okay? According to Henry's law, as pressure decreases, the solubility of the oxygen gas in our blood liquid decreases. So at a high altitude, pressure is less. So less oxygen only can dissolve in our blood. So what happened? Of course, the sufficient oxygen, if not there, it causes what? Anoxia. Right? So connect with the Henry's law. Draw the graph between vapor pressure and temperature and explain the elevation in boiling point. We studied a graph. My dear student, hope you studied that one. What is a graph? As temperature versus vapor pressure, right? So, you know, temperature and vapor pressure are directly proportional. So, we draw like these two lines, very small curve. One is called a solution. The right one is solution because its boiling point is greater. And left side, my dear, we have solvent. Ready? Ready, ready. If you consider a particular pressure at this time, for example, 1 atm, 2 atm, at a particular pressure, let me just find it. What is a boiling point? Okay. What is a boiling point? So it is meeting at this point, ready. And it is meeting at this point, ready. What is this point? This is the boiling point of solution, that is TB. This is the boiling point of solvent, that is TB naught. So the difference will be what? Delta TB, right? This graph we studied, right? In depression in freezing point also we studied one graph where here, right? Where this one comes. This is liquid solvent, this is solid solvent. Hope you remember that. Ready? Okay, that is a graph for this. Give reason for the following. First one, measurement of osmotic pressure method is preferred. Studied or not? Osmotic pressure over other colligative property. Why it is preferred to calculate the molecular mass of the solute? Because it is, you can calculate the osmotic pressure even under room temperature itself. Second, here we are using molarity instead of molality. Molarity calculation is easier. And osmotic pressure we are calculating, using to calculate the molecular mass of macromolecules like biomolecule, polymers, protein, etc. Hope you studied all of you. And this B already repeated question, right? Okay. What is C? Elevation of boiling point of 1 molal KCl. 1 molal KCl. 1 molal, okay. 1 molal KCl. Solution is nearly double than that of 1 molar sugar. Why it is so? Which factor? Elevation of boiling point. See all of. Elevation of boiling point is equal to I into Kb into m, right? See, molality is constant. Kb for a liquid is constant. Delta Tb directly proportional to I value. So for the first solution, delta TB is equal to KCl. What is I value? K plus and Cl minus 2, right? So into 2. What about delta TB of this one? Molality is sugar. Sugar is a non-electrolyte. I value 1. Of course. So here, this KCl solution, delta TB is double of which one? Sugar solution. Because I value for KCl is 2. For sugar, it is 1. Ready? What are colligative property? Come on, my dear. What is the expression? What is the definition for colligative property? The property which depends on number of solute particle or the amount of solute particle, not on the nature of particle. Write the colligative property which is used to find the molecular mass of macromolecule. Which one? Osmotic pressure. We are using the symbol pi. Next. Gas A is more soluble in water, okay? The gas A is more soluble, okay? More soluble in water than B at the same temperature. Which one of the two gas will have the higher value of Henry's constant? You know, Henry's constant is inversely proportional to which one? Solubility of the gas, right? So, A more soluble mean less KH value. Keep in mind. So which one of the two gases will have highest value? Highest value for which one? B, because it's having less solubility. Okay, and why we discussed already. Partial pressure of a gas is equal to what? KH into what? Chi A. From this one, KH is equal to what? Partial pressure of vapor pressure divided by Chi A. See all of you, as KH value increases, the mole fraction or the solubility decreases, right? According to Henry's law. Out of 1 molar glucose and 2 molar glucose, which one has higher boiling point? See all of you, as the number of particle increases, already we discussed many times, as the number of particle increases, here solute is same, right? Glucose, I value same. So check the concentration. Higher the concentration, higher the boiling point. So which one? M, this 2M, because the equation is what? Delta TF equal to I into KF into M. As concentration increases, the boiling point, right? Boiling point increases. Blood cells are isotonic. We discussed osmotic pressure of our RBC equal to osmotic pressure of 0.9% NaCl solution. Ready? What happens if we place RBC blood cell in 1.2% NaCl? See, 1.2% NaCl mean its concentration is more than 0.9, right? More concentration mean it will be which one? Hypertonic solution. It will be what? Hypertonic solution. You know, hypertonic solution particle shrink. What about if you kept a RBC in 0.4%? 0.4 is less than 0.9, so it is less osmotic pressure, so it will be what? Hypotonic solution. In hypotonic solution, RBC swell. Remember, hypertonic solution, it will shrink, hypotonic solution swell. Next, on mixing liquid X and Y, volume of the resulting solution decreases. That means delta V mixing is less than 0. When they mixing two liquid X and Y, volume of the resulting solution decreases. That means delta V mixing less than 0. What type of deviation is this? Where we studied delta V mixing 0, that is negative deviation, right? Negative deviation. What change in temperature would be observed after mixing the two liquid? We know negative deviation where delta H mixing also what? Less than 0. What do you mean by delta H lesser? Mean it is exothermic reaction. That is exothermic reaction. One more data. For negative deviation, you know, AB interaction is stronger than AA and BB. So what happened to their boiling point? Since AB interaction is stronger, they will form maximum boiling azeotrope. Their boiling point will be maximum. So everything is related to the table. What is mean by positive deviation from Raoult's law? Raoult's law, those solutions which do not obey Raoult's law, they are called a non-ideal solution. Non-ideal solution we split it into what? Positive and negative deviation. Positive deviation means PA greater than P naught A into chi A as per Raoult's law. The Raoult's law, PA equal. If they deviate like this, then it will be positive deviation. Similarly, PB greater than P naught B into chi B. Similarly, we have P total is greater than which one? PA plus PB. And also you can say all the points we studied about positive deviation in theory. Delta V mixing greater than 0, delta H mixing greater than 0, AB interaction weaker, and it form minimum boiling azeotrope. What is the sign of delta H mixing for positive? Greater than 0, right? For positive deviation, delta H mixing greater than 0, endothermic. That is the meaning. Ready? Define azeotrope. Tell me all, what are the azeotrope definition you studied? Azeotropes are binary mixture, which means they contain two components having same composition in their liquid state and vapor phase, boils at a constant temperature. And question, what type of azeotrope formed by positive deviation? Which one? Minimum boiling azeotrope. Give an example. Why positive deviation for minimum boiling azeotrope? Because AB interaction is weaker than AA and BB. Give one example for positive deviation. Acetone and ethanol. Right? Acetone and ethanol. Many examples we studied. Ethanol and water. Methanol and water. Right? Many examples we studied. Ready? Explain the following. Henry's law about dissolution of gas in liquid. What Henry's law says that? Partial pressure of the vapor pressure, partial pressure of a gas is directly proportional to its mole fraction in the solution, where Pa is equal to what? Kh into chi A. Boiling point elevation constant for a solvent. How can you define boiling point elevation constant, that is Kb? Do you remember Kb expression we studied? We studied delta Tb is equal to Kb into molality. Right? Consider molality is equal to 1 molal. Then what will be delta Tb, my dear? Delta Tb is equal to what? Kb, right? If molality is 1. So how can you define what is Kb? Molal elevation constant or ebullioscopic constant. How can we define? Kb is the elevation of boiling point for a 1 molal solution. We studied in theory, right? Kb is the elevation of boiling point for a 1 molal solution. Like that we can define it. For a 5% solution of urea. So what do you mean by 5% urea solution? Urea solution. We can say that 5% urea means 5 gram urea dissolved in 100 ml of water. 100 ml of water. And so what is the 5%? 5 gram urea, that is the weight of solute, that is 5 gram, and volume of the solution is given 100 ml. So in liter divided by 1000, right? So that we can, okay, better to convert into which one? Liter, 0.1 liter. Ready? Question, and molar mass of the solute is also given, my dear. MB is given 60 here, right? Urea gram per mole. Calculate the osmotic pressure. So pi we need to calculate at a temperature 300 Kelvin. The R value, universal gas constant already given. What is our equation for that? Pi equal to I into WB by MB into V into RT. So pi is equal to, what is the Van Hoff factor for urea? 1. Urea, glucose, sugar, benzene, these all are known electrolyte, I value 1. Into WB is given 5 gram, MB given 60 gram into volume. What is the volume? 0.1 and R 0.0821 into temperature 300. All of you work down. Pi value you will get around 20.5 ATM. So we have to discuss more questions. So I'm just giving you the data how to do that one. So pi equal to what? 20.5 ATM. So osmotic pressure is a frequent question for the board exam for the numerical. Okay, careful. Next one, calculate the mass of ascorbic acid to be dissolved in. So ascorbic acid is a solute. So its weight supposed to calculate. Its molar mass is already given 176 gram per mole. To be dissolved in 75 gram acetic acid. So that is a weight of solvent, that is 75 gram. And lowered its freezing point. So delta TF is given to you around 1.5 degrees Celsius. KF is also given 3.9. So directly we can apply our equation. Which one all? Delta TF is equal to I into KF into WB by MB into 1000 divided by WA. Delta TF is 1.5. I value, ascorbic acid, that's those I values are 1. KF, what is KF? 3.9 into WB is supposed to calculate MB 176 into 1000 divided by weight of solvent is 75. So WB is equal to 1.5 into 176 into 75 divided by 3.9 into 1000. Check it all of you. Around 5.08 gram we can get it. Another one. A solution contain 5.85 gram NaCl. So weight of solute is given here 5.85 gram. Ready? Molar mass MB is given 58.5 per liter. So volume of the solution is 1 liter. It has an osmotic pressure. So volume is 1 liter. Osmotic pressure is given 4.75 atm at a temperature of 27 degrees Celsius in Kelvin plus 273 around 300 Kelvin. Calculate the degree of dissociation alpha for NaCl. What is the expression for degree of dissociation? I minus 1 by N minus 1. Right? So this all data given to calculate what? I value. N value we already know for NaCl. How many ions given by NaCl? 2. So I minus 1 let us calculate and 2 minus 1. So I value what we need, that's we need to calculate through the expression. What is the expression for osmotic pressure? Pi equal to I into, what is I? I value we can take, okay, I value supposed to calculate, right? So pi is already given, right? 4.75 equal to, what is our equation? Pi equal to I into WB by MB into V into RT, right my dear? So osmotic pressure is given, Van Hoff factor into WB is 5.85, MB is 58.5 and volume is 1 liter into R value 0.082, right, into the temperature is how much? 300 Kelvin. So we will get it as, okay, right? So I value you have to calculate first. I value you will get it around 1.93 by solving this one. So I value 1.93, right? So it will be equal to what? 0.93 divided by 1. And you know alpha is mostly expressed in percentage. So we can multiply by 100. That is equal to 93% is dissociated. Like that we can able to calculate the degree of dissociation. Another question. 10% solution of sucrose. Okay. So 10% solution of sucrose is there. Okay. In water has freezing point of. So freezing point TF is given 269.15 Kelvin. Ready? Calculate the freezing point of 10%. Another solution with a 10% glucose is there. It's a TF we need to calculate. Okay. In water, if it's freezing point of pure water, freezing point of pure water is given. What is the pure water TF naught? 273.15 Kelvin. Even here also TF naught is 273.15, right? Yes, my dear. They given same percentage of glucose and sucrose solution. Its freezing point of the solution is given. Its freezing point we need to calculate. Solvent is, water, that is constant. So how to calculate? If they ask, and one more thing, molar mass of sucrose is given. So its MB is given is 342 and molar mass of glucose is given here 180. So very simple here all. The calculation is very easier actually. Like if they given two solution and they are asking one data, write the expression for both of them, take the ratio, that's it. So what is the factor here? Delta, the depression in freezing point, right? Okay, let's be consider. So I can take delta TF is equal to what? I into KF into WB by MB into 1000 divided by WA. That is our equation, right? Yes. Now, I'm taking for both of the solution. First one for sucrose solution. What is delta TF? TF naught minus TF, right? Okay, let me write instead of delta TF is what? TF naught minus TF. So what is TF naught? 273.15 minus TF is given 269.15 equal to I value for sucrose and glucose 1, right? Leave it. KF for a solvent is constant, right? That is, water is the solvent, for KF is a constant. So KF will be, take it as KF, because when we take in the ratio, automatically cancel. What is WB? WB, yeah, 10% solution means what? 10 gram. So weight of solute is 10 gram. What is the molecular mass of solute? 342 into 1000 divided by, what is weight of solvent? Can you say? See my dear, 10% sucrose mean 10 gram sucrose in 90 gram. 10 gram sucrose in 90 gram water. So weight of solute is 10, weight of solvent is what? 90. So divided by 90. So here what we, okay, this is for first solution. What about the second solution, which means glucose? Where TF naught is, how much is the TF naught? TF naught is same, right? So 273.15 minus TF is to supposed to calculate equal to KF into 10 divided by, what is its mass? 180 into 1000 divided by how much? It's 90, right? Because 10%, right? Okay. So this is, take it as equation number 1 and equation number 2 and take the ratio. 273 minus 269, around 4, right? So 4 equal to KF into 10 divided by 342 into 1000 divided by 90. And here 273.15 minus TF equal to, okay, that's it. So let us take the ratio. Let me take, this is equation number 1 and equation number 2, taking the ratio 1 by 2. Okay, taking the ratio 1 by 2. So here we have 4 divided by this one, 273.15 minus TF equal to, here the right side what we have? KF into 10 into 1000 divided by 342 into 90. When you divide this, if it comes, this numerator go to that, right? So it will be 180 into 90 divided by this KF into 10 into 1000 comes. Okay, you write slowly. So we can cancel the one KF we can cancel, 1000, 10, 10 cancel, 90 cancel. So we have 4 divided by 273.15 minus TF equal to, what is that? 180 divided by 342. 180 divided by 342 while you're doing, it's very close to 16 around point, yeah, 180 by 342, right? So 180, 360. So it comes around 0.53. So we'll get this, this comes around 0.53. So you can get 4 divided by 273.15 minus TF equal to 0.53. You will get it. So take the values and all, calculate TF and simplify all. I hope you will get that answer around, yeah, 265.53 Kelvin. We get it. So basically, when solution chapter, when they ask previous year question, mainly you have to stick on theory is very simple, right? Theory is very less. So less theory is there, more numerical we have to practice it. So these kind of ratio taking questions and all are repeated one. So study the chapter solutions carefully, thoroughly. Wish you all the best.